Hey everyone, it's Ryan with This Smart House, and on today's video, we're gonna be doing part 2 of last week's video, talking about our do-it-yourself busy light. Now in this week's video, we're gonna be taking a look at the ESPHome project and how it powers my smart light. So if you're not familiar with ESPHome, it's a project that is maintained and operated by the same team as Home Assistant. It allows you to take an ESP32 or ESP8266 based device and turn it into your own sensor, light, what have you. It's the control package for your own home-built sensors. So on today's video, I'm gonna show you how to install and set up ESPHome, how to flash a device and get it added to your wireless network, and then the configuration and automations that I use to control this light. Let's head in the office and take a look. All right, so for this next section, let's go ahead and get ESPHome installed in my test environment, and then we'll move on to actually flashing the ESP device. So the first thing you need to do is go into your Home Assistant instance, go to Configuration, and go to Add-ons. Go down to the Add-on store, and search for ESPHome. It should be part of the community add-on, so you should not have to add anything to get there. So click there. So click on ESPHome, and click Install. Now that should take just a minute or so to get the software installed in your instance. Once that's done, we can go ahead and click the Start button here. There is no necessary configuration here, so it should start right up. And then it's going to create a web UI, so we'll click on that. So then you're presented with Welcome to ESPHome. Let's create a new device. All right, so before we create our first device, let's go ahead and click over here to Secrets. This is where you want to put in your Wi-Fi SSID and password. This is important because just like Home Assistant, it uses a secrets file to keep those separate. So it's very simple for you to copy your configuration and paste it out on the internet. And then somebody else can just grab that configuration, drop it into their device, and it will automatically replace the SSID and password. So if you have any other secret keys you want to use, you can define those in this file and then reuse those in all of your instances. So we'll go ahead and hit Save, Close. All right, so now we're gonna create a new device. Now for this device, I'm gonna use one of my 8266s that are lying around. Again, you can use either an ESP8266 or an ESP32 with ESPHome. Now in my actual status light, I've got an ESP32, and that code that I posted on my blog post is for an ESP32. So for this, I'm gonna go ahead and show you how to do it with an 8266, but I'll have both versions of the code on the blog post. And now I'm getting a pop-up warning here about not being able to communicate over an HTTPS connection. Now this is just because I'm using my test environment, which is obviously only in my network. You probably won't see this one, especially if you're using something like Nabukasa, or you've got your port forwarded inward and using something like Nginx or Let's Encrypt with DuckDNS. Since I'm getting this error message, I'll show you how to do it the manual way. You can also just plug it in and use the web terminal flasher if you're using a compatible browser and using HTTPS. So don't worry about this error message here. Like I said, I'll show you the manual way to do it. Okay, so we'll hit continue. And we need to give this a name. And again, it shows you it can only be lowercase letters, numbers, or a dash. So we'll call this one Busy Test. Now again, I'm going to be using an 8266 here, but this is where you'll need to decide which type of chipset you're using. So I'm gonna select 8266. I'm gonna select 8266. And there we go. Now we have a configuration created. It's saying install here because it wants you to go ahead and flash your device so that it can get the Wi-Fi information on there and the ESPHome code. Once you get the Wi-Fi information on here, then you'll be able to update this over the air. So you could set your device up, install the base configuration on there, and then actually move it someplace to test it and then update it with newer software later on. So we can go ahead and click install here, and this is where it's going to give you your options. Now if you're doing this over an HTTPS browser, with something like Chrome or Edge, you can use the plug into this computer option. Because I'm doing this manually, I'm going to be selecting the manual download and then using the ESPHome flasher to flash the software. So click manual download. So it should take just a minute to go ahead and compile the software, and then it will download the bin file in your browser. So while this is happening, let's go ahead and download the ESPHome flasher. And again, if you are using a compatible browser, you can skip this step, but I want to go ahead and show you for completion's sakes. So to get the ESPHome flasher, you can either go to Google and search for it, go to the GitHub page, releases, and then find the release for your particular platform, or go to this URL that I have down here below. It'll take you straight to the latest releases page for the GitHub flasher. All right, so I've downloaded the Windows X64, which is here, and I've already done this a couple of times, so I've got that already. So let's go ahead and open up the exe file for the flasher. Now you will get an error message if you're running Windows 10 or Windows 11. You can go ahead and hit more info and then run anyway. This is just because of the way that it interfaces with your computer to run the flasher. You'll find this very commonly on a lot of other Arduino type flashers. All right, so here is the ESPHome flasher. Now that the file's compiled, we'll go ahead, it pops up and asks me to download the bin file, which I'll click OK for. So go ahead and take our ESP device and connect it to our computer. So I'm gonna go ahead and attach this to my computer. And if you do run into problems, I have a troubleshooting section in the blog post where it'll take you to the drivers to download for Windows, just in case it doesn't pre-download them automatically. I've attached the device to my computer and click the refresh button here. Now I've got COM port 7. This COM port 3 won't be correct, so we'll go to COM port 7, and then we want to hit browse to grab our bin file, and we can click flash ESP. So this will take just a minute. It's going to go ahead and flash the initial software on your ESP device. Then you can test to ensure everything's communicating properly, and then you can go ahead and make your updates from this point forward using the over-the-air wireless flasher. So this is nice because it shows you all of the Wi-Fi access points it has access to, which of course I've blurred out, and it'll tell you if it has any trouble connecting to your Wi-Fi. So this is a good way to troubleshoot if you get the password incorrect in your secrets, or if you're having some sort of problem with your Wi-Fi. So after we waited a little bit, it's gone ahead and connected to the Wi-Fi. We show that it's connected. It's got a host name. So let's switch back over to our ESPHome in Home Assistant. We'll close out of the installer, and then if you look, it says Busy Test Online. Now, if it shows online here, it means that all the functions that you've programmed in are operational and you can access this and wirelessly update it. So you can click on here to edit, and as you make your edits to the code, then you can go and install and use that wireless installer from this point forward. So now that we've got a functional device connected to our network, let's go ahead and jump into what the programming looks like for the Busy Light, and I'll take you through line by line what each of them mean for the specific example and how it works. All right, so now we're going to go ahead and actually program the ESP device for our project. Now, if we saw in the last video, this project consists of an ESP device and an attached WS2812B or NeoPixel compatible LED strip. Now we're only using 3 LEDs on the strip, so it's a pretty simple configuration, but I want to go ahead and show you line by line how to set these up and what each of these elements mean in the code. Now again, I'm using an ESP32 device in my specific instance, but I'm going to show you where in the code to change between ESP8266 and an ESP32. It's just a simple couple lines at the top of the configuration where you define this. If you go to the blog post from last week's video or this week's video, both of them contain example code that I'm going to be using from today. It's pretty simple. It gives you a good example of what you can do with the ESPHome project. So here we are on the code example. Again, this is from last week's, so I'll have this look a little bit different for this week. All of these top items up here that are already defined, we can go ahead and ignore. We want to start down here where it says light. So I'm going to go ahead and grab all of this, copy it, and then we'll head back over and we'll go back to our ESPHome configuration and click edit. All right, so if I bring these code sets up side by side, I'll take you through kind of the configuration of how these work. So if we look, our first line is always going to be ESPHome all the way to the side, and then the name of the device. Now, this obviously was already defined when you go through your setup, but you can change this later on if you want to. Then we define the type of board we're going to use. On the left here, I have an ESP8266, and then it auto-detected this ESP01 board type. Over on the right, we'll see it says ESP32, and the board is the ESP32 development board with the framework defined. Again, when you first select that radio button between ESP8266 or 32, then that's where it inputs that code. So again, this is just an explanation. You don't need to worry about this, but I'm showing you what these lines mean. Then it defines some standard items like logging, the API call for Home Assistant API, an over-the-air password that is shared between your device and your Home Assistant instance. That way, this OTA update is secured and a malicious person can't come on the network and inject their own code. Then we define the Wi-Fi, SSID and password, and again, those are contained in the secret file. Then it has what's called a fallback hotspot defined with a captive portal. This is very similar to what was on the ESP Presence project, where in the event that it cannot connect to these SSID and password, and the Wi-Fi errors out, it will create its own access point that you can access with, say, a phone using this SSID and password. And then when that happens, it'll open up a captive portal that allow you to redefine the Wi-Fi information. Pasted everything in, so we'll remove all what's not needed. All right, so we pasted in our code. I'll scroll in here so you can see side by side. So then this is the light platform. Again, with this example, we're only doing lights. But if you were doing something like temperature or a relay, an input or output, you would define these each as a section going down through it. And just like you would in Home Assistant, where you're defining your sensors, your binary sensors, your cameras, you just have each section broken down by what type, whether it's light or temperature, whatever it is. And then you can bring in as many different types of commands on your board that it can support. So in this case, we're just doing the light platform, and we're going to be using the NeoPixel bus platform. They already defined the type is green, red, blue, and if you have problems with it, you can invert those or change the type around. It has more instructions. If we go under the light components, you'll see I got this example from the NeoPixel bus light example. So we click on that, it'll explain in more detail what each of the components mean in the system. So then all this is pretty standard. Then we have the variant, which is WS2811. which this is a 2812, but it's the same one. If you look down here, we can replace that with the 2812X. It doesn't really change the performance all that much, but it's good to have it line up with the type of light we're using. So then next down here, we have the pin. Now this is important to pay attention to because this depends on what pin you soldered to in the last week's video. So if you soldered, say, to GPIO1, GPIO2, you want to make sure that you select that here or input that number here. Now, please make sure you use a pinout diagram for your particular chip because, say, one manufacturer may have a different pinout than the other one. They're pretty standard, but you want to make sure that that I/O pin lines up with the proper GPIO on the chipset. So then we gave it a name, NeoPixel Light. So on effects, I've defined a few effects that we can use under the pulse section. So if you'd like to see a list of all of the effects, you can click on this link here. So this is on the ESPHome NeoPixel bus light documentation. There's a link to the list of all the light effects that are supported, and you can copy and paste any of these effects out that you want. I just have some basic ones put into mine right now. So those are a fast pulse, where it flashes on and off every half second, a slow pulse, which is a 2-second pulse that I utilize more often when I'm indicating whether or not I'm in a call, and then a flicker effect, which is kind of like a candle flicker. So those are some of the basic ones that are defined there. That's all you really need to define for this particular project. So once we're done, we'll go ahead and click Save. It looks like it's been saved, so we'll click Install, and now we can select the wirelessly to flash it. Now it's going to go ahead and compile the code, and then when it's done, it will send the over-the-air communication using that password it defined, and then go ahead and self-update. So once you click that, it's going to compile the code. Then it will communicate securely using that passcode it defined, and send the new bin file to the ESP chip so it can self-flash. Once that's done, it will reload, come back online, and then you can check the logs to make sure everything flashed correctly. And it will take a few minutes once it gets the new configuration for it to flash and update. So once that's finished and it comes back online, you'll see information here in the logger about it being online. Then it should, we'll hit close here. We can pop back over into our configuration, go into integrations, and now you'll notice that a new device has been discovered automatically. You'll need to click Configure to load this into Home Assistant. Now what this is doing is, obviously we're using the add-on to control and build our ESPHome project, but once it's online, it sends a signal to Home Assistant and asks to be set up. That way you can select and say, yep, set this device up in my instance, and then you can control the light and see data in Home Assistant. So we'll go ahead and click Submit here, and it set itself up. So now that the device has been added into Home Assistant, we can click One Device, and we'll see we've got a NeoPixel light here. So we can now control the light. We can now control the light, turn it on and off, and just like any other light in Home Assistant. So now that everything is set up, this is a good time to go ahead and test to make sure your LED strip is working correctly. So I'd recommend turning it on, making sure the lights turn on. Do the lights look like the correct color? Go ahead and take it through some different color configurations. Set the brightness to full, and then go through some different colors. Make sure the reds look like red, the greens look like greens, the blues look like blues. If they don't, then you might need to change that RGB order in the system. If you don't have any light at all, then that probably means you've either connected to the wrong GPIO pin, or you might want to go back and check your soldering job. If all the pins are connected and you've already taken a multimeter to it to make sure that you've got 5 volts going in the right pin, ground going in the right pin, and the data pins connected to your input. Now you also want to make sure that you have the correct GPIO pin selected in the code. Again, refer to a pinout guide for your particular chip to ensure you have the right GPIO, because it is possible that an IO number and a GPIO number are different from each other. Once you've done all that, you should have a functional light that you can now test and put wherever you want. So in the next section, we'll go through some automations and some extra softwares that I like to use to round out this light. All right, so now that we have a functional light that works, responds in Home Assistant, let's set up some automations to make it actually functional as a busy light. Now, before we jump into the automation section, let me show you some of the softwares that I'm currently using that helps to feed some more information about your local computer into Home Assistant. So the first piece of software is actually an accompaniment to a hardware product called MuteSync. Now, what MuteSync is a physical button, very similar to what we're doing, but it's actually a button that is used to control the on-off of your microphone. So they have a MuteSync virtual mute button that can actually integrate directly with Home Assistant. What it does is, as you see here, so MuteSync actually has a free virtual button that integrates with things like Teams, Meet, Zoom, and that let you get the status of your meetings and bring it into the MuteSync application, and then MuteSync talks to Home Assistant and feeds that information over. So the way it works is there are 2 binary sensors that it creates in Home Assistant. One's called in a meeting and one's called microphone muted. You can pull those statuses in a Home Assistant and use them for your status light. So setting up the MuteSync app is super simple. All you need to do is download it for your particular platform, get it installed, set the preferences that you want, and then bring up the preferences before you install the integration in Home Assistant. There's an authentication tab here, and tick this Allow External App. And make sure you leave this window open in the background. That way, when Home Assistant reaches out, it allows it to authenticate. So we'll click Add Integration, search for MuteSync, and then type the IP address of the machine that MuteSync is installed on. And there it goes, it's added it in. You can add it to an area, hit finish. And then if we bring up the 2 entities, we'll see we've got a binary sensor in meeting and a binary sensor muted. So the way that works is it will detect if you're in a Zoom, Google Meet, Teams meeting, and pull that status into Home Assistant, and then we can use these binary sensors in our automations later on in combination with the Teams status that I showed you a few weeks ago. If you haven't watched that one already, I've got a link in the cards right up here. So using that information plus some other information that Home Assistant knows, I'm able to change the status light for a lot of different options. So as we jump into the automations, you'll see how I use these 2 binary sensors in my automations to change the color of my status light. So I swapped over to my live environment to show you how my automation works. So because this is such a long automation, I have posted the entire thing in the blog post, which is linked here below. If you want to, you can just copy that and modify the certain pieces for your environment. Now, I will say that you might need to tweak this quite a bit because this is very much set for my environment. I'm going to take you through each step on the YAML side so you can see exactly what everything does. So we start off here with obviously a name, and then we have all of the trigger platforms. So in this section here, you're going to want to list out every single solitary item that you want to trigger this automation. So anything that you want when it changes state for it to trigger the automation, it needs to be in this list. And you'll notice I just have a state and entity ID for each entry. There isn't an actual state that we are looking for because we want to know each time it triggers, because this is all encompassing when things turn on or off. It takes care of all of it. So that's why there's no actual state listed in here. It's just every time it changes state, it will activate this automation. So this automation is going to run a lot, but if it doesn't match any of the criteria, then it will actually turn the light off, or it won't change the state if it's already in a current light state. So if the light is red and it calls for it to be red, it's going to stay in red. So you'll notice I have that input select from the team status from a few weeks ago. I've got the 2 binary sensors that we just set up a second ago with the MuteSync integration. I have the Xbox that's here behind me, and that's just a fun automation, and you can ignore that if you don't care. I have my light will change blue or green depending on if my son or I are playing Xbox in here. So these next 3 ones, if you don't want to do that, you can skip that entirely. So then I've got a binary sensor with the Xbox integration that tells me if he's online. I've got if I'm online, I have the entity ID of my monitor switch. So these two monitors are actually on a smart switch. So when I come into my office, I can press and hold the up button on this remote, and it turns on the screens and turns on the lights under there. That's how I know if I'm actually working in the office, because if this is on, then I'm in here working. Then I have my state, whether or not I'm home. And then finally, I'm pulling a little bit of information from my phone. So if you already have the Home Assistant app installed on your phone, there is a sensor you can activate that tells you the phone status of your phone, whether it's on or off hook. So this is convenient. So I know if I'm on a phone call, if I get a phone call to my cell phone during the middle of the workday, I want the light to change to say I'm on a call. So I have that established as well. That's all the triggers. Then we go into the condition, which I don't have any conditions because I'm doing all the conditions as part of the actions. For the actions, I'm using the choose function. Now, again, what this does is it's sort of an if then else setup for Home Assistant. It'll basically look at each condition in order, and if it hits one of those, it'll perform that action and then quit. So this is great if you're doing certain states. So if you have state 1, state 2, state 3, state 4, it checks to see if that state's valid and then activates it and then stops. If you do not meet any of those criteria, it'll do what's called the default action, which if you don't want it to do something, you just leave that default action blank. But in my case, I have it turn the light off. So if it doesn't match any of the criteria here, it turns the light off. So the first and primary state is the condition. It looks that these all have to be matched. The conditions under the actions are an and. So each one of these has to be valid for it to move on with this particular step. My team status has to be available. It has to be between the hours of 8 and 5, Monday through Friday. The in-meeting sensor has to not be on, so condition not. I have to be home, and the Xbox has to be turned off, because if I'm playing Xbox in here, then that will be on, and I don't want it to tell me that I'm available. So as long as all those things are valid, then it's going to run the service turn on light, turns on the office status light, changes it to white 100% with no effect. So that's just solid on white. The next condition is, so again, still part of that choose. The next condition, that's the second option, would be when I'm done for the day. So if I'm either away or any of these other things are met, which is outside of after 5, before 7, I'm not in a meeting, I'm home, the Xbox is not on, or any of these other conditions, then it turns off the status light. Pretty simple. Then I have the third condition is the busy light condition. This is if my team status is either busy or do not disturb, it turns the light on red to 100% with no flashing. The fourth state is the away state. So if my team status is away during the hours of 8 to 5, Monday through Friday, then it changes my light to yellow. I need to actually update this with me being home. So then this is the key one. This is the one that actually has my light turn red and flash to tell people do not come in for any reason unless somebody's bleeding or the house is on fire. So that is a set of or conditionals. So these top 3, if one of these 3 are valid, it will move on. Whether that's I'm in a meeting, so my team status is in a meeting, my team status is in a call, or all 4 of these are correct. Or, so the condition, one of these 2 have to be valid, or all of these have to be, which is my phone's off hook, I'm home, my phone shows up as in the office. This is using the ESP Presence integration, and it's between 7 and 10 p.m. any day of the week. So if I'm in a meeting, I'm on a call, or all of these conditions are valid, then it turns on the light red at 100% with a slow pulse. And then finally, I have if the Xbox is on and my son is playing, turn the light blue. And then there's this default condition that I was talking about before, where in the event that none of these are valid, it turns the light off. So again, that's just a step through of how my automation works. You can tweak this to your own customization and liking. I would advise taking out some of the information. I'll actually post a simpler version, which will just contain a few of the elements. I'll take the Xbox stuff out. So there'll be 2 versions of the blog post. It's up to you how you want to take care of this, but that's how I do my busy light. And so far it's worked pretty well. I've had to do a few tweaks here or there just to make sure that the lights, the correct status, I've had it turn on in the middle of the night. And so that's why I've added those time gaps in there, because you don't want a creepy red light blinking on and off when you're trying to sleep. So there you go. That is how I set up and use my smart light. Hopefully today's video was helpful for you to get into the ESPHome project and also follow through with the rest of this project. If you do have questions, please feel free to visit our Discord, which again, I've got linked at the bottom here below, or post a question in the comments below. Now, if you'd like to see more home assistant projects, click on this playlist here. If you want to let the algorithm select your next video, click up here. And as always, if you haven't already, make sure you subscribe to the channel by clicking our logo right here. Thanks again, and I'll see you in next week's video.